Welcome to video 4 for this unit on functions and volume. In this video, we're going to focus on cylinders and cones. Here are two cylinders, D and E. A cylinder is a three-dimensional figure like a prism, but with bases that are circles. When filling a shape like a cylinder with water, we can see how the dimensions of the cylinder, the radius, and the height affect things like the changing height of the water. Cylinders D and E have the same height, h, but D has a radius of 3 centimeters and E has a radius of 6 centimeters. If we pour water into both cylinders at the same rate, the height of water in D will increase faster than the height of water in E due to its smaller radius. If we graph the height of the water for each cylinder as a function of the volume of water added, we have two lines, and the slope of the line for cylinder D is greater than the slope of the line for cylinder E. The volume of a three-dimensional figure, like a jar or a room, is the amount of space the shape encloses. We can measure volume by finding the number of equal-sized volume units that fill the figure without gaps or overlaps. Just like a rectangular prism, the volume of a cylinder is the area of the base times the height. For example, take a cylinder whose radius is 2 centimeters and whose height is 5 centimeters. Since we know the height, we just need to calculate the area of the base. The base of the cylinder is a circle with radius r, so the base area is pi r squared. The base of this cylinder has an area of 4 pi square centimeters, since pi times 2 squared equals 4 pi. This means the volume is 20 pi cubic centimeters, since 4 pi times 5 equals 20 pi. Using 3.14 as an approximation for pi, we can say that the volume of the cylinder is approximately 62.8 cubic centimeters. In general, the base of a cylinder with radius r units has area pi r squared square units. If the height is h units, then the volume of a cylinder in cubic units equals pi times r squared times h. This means that if we know the radius and height of a cylinder, we can find the volume. It is also true that if we know the volume in one dimension, either radius or height, we can find the other dimension. For example, imagine a cylinder that has a volume of 500 pi cubic centimeters and a radius of 5 centimeters and an unknown height, h. From the volume formula, we know that 500 pi equals pi times 25 times h must be true. Looking at the structure of the equation, we can see that 500 equals 25 times h. That means that the height has to be 20 centimeters, since 500 divided by 25 equals 20. If a cone and a cylinder have the same base and the same height, then the volume of the cone is 1/3 of the volume of the cylinder. For example, the cylinder and cone shown here both have a base with radius 3 feet and a height of 7 feet. The cylinder has a volume of 63 pi cubic feet. The cone has a volume that is 1/3 of that, or 21 pi cubic feet. If the radius for both is r and the height for both is h, then the volume of the cylinder is pi times r squared times h. That means that the volume of the cone equals 1/3 times pi times r squared times h. This means that if we know the radius and height of a cone, we can find the volume. It is also true that if we know the volume in one dimension, either radius or height, we can find the other dimension, just as we did with the cylinder. For example, imagine a cone with a volume of 64 pi cubic centimeters, a height of 3 centimeters, and an unknown radius r. From the volume formula, we know that 64 pi equals 1/3 pi r squared times 3. Looking at the structure of the equation, we can see that 64 equals r squared, so the radius must be 8 centimeters, since 8 squared equals 64. Thank you for watching video 4 of 5 for this unit on functions and volume.